Hello, today's video is on 12.3 probability. Probability you are pretty familiar with. I'm sure you've done probability of different things throughout school. We're going to take it up just a notch, but we're going to start by reviewing the basics. Probability is the measure of the likelihood that an event will occur. So it's the favorable outcomes, it's the positive. Probability values will always range between 0 and 1. It will never be negative, it will never be greater than 1. Probability can be expressed in three different ways. It can be written as a decimal, as a fraction, or as a percent. Generally, we're going to write our probability as a fraction. However, do pay attention to the directions to see if you're supposed to write it as a decimal or as a percent. When we look at this scale of probability, we know it's between 0 and 1. If the probability is 0, that means it's impossible. It will never happen. If the probability is 1, that means it's 100% going to happen. It will happen no matter what. There's no option but it happening. Then we look at everything in between. If the probability is 0.5, it occurs about half of the time. If it's about 0.25, that's 1 in every 4 times, so it's pretty unlikely. If it's 0.75, it's quite likely. It's 3 out of every 4 times it's going to happen. So the closer to 0 the probability it is, the more unlikely. The closer to 1, the more likely it will happen. Generally, you probably are familiar with what we call theoretical probability. And theoretical probability is the number of ways that it will occur divided by the total number of possible outcomes. And theoretical probability is just theoretical because it's made up. We're saying, given a situation, what would most likely occur. We're not actually doing the situation. So for number 1, there are 9 players on a high school baseball team. The coach draws names one by one to determine the batting order. What is the probability that 3 of the 5 seniors will bat first in any order? So we kind of break down our information that we're given. We know that we have 9 total players. What is the probability that 3 of the 5 seniors will bat first? Well, if we have 9 players, if we have 5 seniors, that means we have 4 others. So I kind of always start by breaking down what are the pieces that I'm given. On top is the number of ways that it's going to occur. What we're trying to find is 3 of the 5 seniors. The order is not going to matter, so we're going to use combinations. And on the bottom, we want the total number of possible outcomes. The total number of players that we have are 9. So the total would be 9 choose 3. On top is only the likelihood that's going to occur. That's why we're only choosing out of 5. On the bottom, it's the total, and the total is choosing out of 9. So that gives us 10 out of 84. Reduce your fraction. So when we write this, we can either be 5 out of 42. If I wrote it as a decimal, it would be about 0.119. If I wrote that as a percent, we just put the decimal to the right twice, and that's 11.9%. So any of those options as our answer would be correct. For number 2, you put a CD that has 8 songs into your CD player. You set the player to play the songs at random. The player plays all 8 songs without repeating any of them, so no repetitions. Part A, what is the probability that the songs are played in the same order as they are listed on the CD? If they are looking to play in the exact same order, you have to think again, when I write this out, how many will make it possible? That's the top number. On the bottom, how many total different ways are there to make it happen? So there's in this case, there's only one right way. There's only one way that it can play in the exact same order as the CD. What we have to find is the total possible different ways. And in this case, if there's 8 songs, there's 8 for the first song to play, there's 7 options for the second, 6 for the third, and so forth, which gives us an 8 factorial. So the probability that the songs are going to be played in the exact same order that they are listed on the CD will be 1 out of 40,320. And if you were to list that as a decimal, it would be 0.0000248. And you guys know that if I want to go from a fraction to a decimal, I just divide that in my calculator. So again, when we're dealing with probability, just remember that the top number is how many ways can you make it so that it's successful, so that it comes true, and the bottom is how many ways total can you make it. In part A, there was only one way to successfully play it in the exact same order as the CD. For part B, you have 3 favorite songs on your CD. What is the probability that 2 of the favorite songs are played first in any order? Okay, so it's getting a little bit more complicated because we're choosing songs. You have 3 favorite songs. We want 2 of your favorite. So if I'm going to successfully choose 2 of my favorite, the ways to be successful are 3 choose 2. But on the bottom, it's the total different ways that we can pick any 2 songs. What is the probability that 2 of your favorite songs are played first in any order? So top, again, is how many ways can I be successful. If I want to successfully choose my favorite, I have 2 out of 3 ways to choose that. On the bottom, I'm still choosing 2 songs, but I may choose my favorite song, I may not choose my favorite song. I'm looking at all the different ways that I can choose any 2 songs. Well, there's 8 songs on the CD, so that would be 8 choosing 2. We plug that into our calculator, and we get 3 over 28, which when we divide that, we get 0.107, which is about 10.7%. Again, you want to concentrate on the way that the question is asked on homework or on quizzes to see whether you should be giving a fraction, decimal, or percent. If you're not told, then write it as a fraction. Okay, so that is theoretical. That is in all circumstances made up, so what would be the likelihood? When we look at experimental probability, it's saying, okay, we actually did the experiment and these are the numbers that we came up with. Maybe it'll match the theoretical, maybe it won't. Just like if I roll a die, I know that, or let's flip a coin. You've got heads or tails. Theoretically, you have a 50% chance of flipping heads, a 50% chance of flipping for tails. Theoretical is just what are the odds. If I look at experimental, let's say I flip a coin 10 times. I may get 5 and 5, I may get 4 and 6, I may get 3 and 7. So theoretical is just what are the odds with everything being true value. Experimental is you actually did the experiment and those are the numbers that you came up with. So for number 3, 9th graders must enroll in one math class. The enrollments of 9th grade students during the previous years are shown in the bar graph. Find the probability that a randomly selected student is enrolled in honors geometry. Well, again, the formula is the same. It's successes on top, total on the bottom. So I want to look to see how many kids are actually in honors geometry. There are 36 kids in honors geometry. Well, I'm going to put that over the total number of all freshmen. So I have to add up 87, 36, 69, and 51. When I add up all those, I see that I get 243 total students. So 243 is going to go on the bottom. When you are writing your probability, it should always be written in lowest terms. So our probability here, which would be 4 out of 27. Then I want to find the probability of Algebra 1 or Intro to Algebra. Yesterday we talked about the word or, and if I'm using the word or, I am adding. So if I have Algebra 1, I've got 87 students in Algebra 1, and I look at Intro to Algebra 1, I've got 51. So those are all the ways I can successfully choose Algebra 1 or Intro to Algebra. And there's still 243 students total, which gives us 138 different ways I could successfully choose Algebra 1 or Intro to Algebra out of the total of 243 students, which is going to reduce down to 46 over 81, which will be the probability of choosing Algebra 1 or Intro to Algebra. Alright, our last problem for our notes. Finding the probability that a randomly thrown dart would hit the shaded portion of the target shown. And this is going to be an excellent question that you're going to see again, hint, hint. So we have our setup here. So we're kind of talking about like you're going to a carnival and hopefully everyone's seen those carnival events where there's the balloons on the board and you're throwing darts and you're trying to pop the balloon. So we want to find out the probability that a randomly thrown dart will hit the shaded portion of the target. So here's shaded, 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 out of the entire target. So just remember, it's success over total. So the success would be the probability of the shaded region. The total would be the entire board. So if I'm looking at the whole board, I want to find the area because I want to find everything inside of there. So if I want to find the total area, I've got one rectangle, which would be base times height. In this case, our base of our target is 4 feet. The height of our target is 2 feet. The shaded region, we have 1, 2, 3, 4, 5, 6, 7, 8 circles. And again, I can hit anywhere on that circle, so I want the shaded area, the area of the circle. The area of a circle is pi r squared. Well, we have 8 of those circles. When I look at my diagram, I see that my radius is 0.5, so that's pi 0.5 squared. Now this is probably the one time where I'm going to say we're not going to be using our exact answer, our fraction on your quiz. I'm going to say round. Because we have pi, we're not going to have an exact answer unless we have pi in our answer and we want to find the actual number. Don't use 3.14, use the actual pi button on your calculator. So on top we multiply 8 times pi times 0.5 squared, all divided by 8. And we're going to get about 0.785 as our probability. And that was our last question for today. We will continue this tomorrow in class.